all, and this is the editorial for problem I, or task I, coins of the educational DP contest on AtCoder. So, essentially what this problem is we have n coins, each of them has a probability pi to be heads, and obviously the probability for tails, given that, would be 1 minus pi. And all you need to find out is, given Taro has tossed n coins, find the possibility of having more heads than tails. Okay, and n is 2999. Weird number. Okay, so let's see what we've got. One way to do it, of course, is to try, is to just guess every possibility, if every combination of heads and tails, and find the probability. That's easy enough, right? O of n, and then, add, get only the ones that have more heads and tails than that. But obviously that's 2 to the power of n times n, which is way too much. So let's see how we can do it, maybe in a linear fashion. It looks like we can do that. So what can we do here? Okay, so for each person, or for each coin, you have some probability, and either you get heads or you get tails. So if you get heads, then the count of heads from whatever it was before is increased, and the count of tails, if you get tails, then the count of tails increased. Okay, so let's say, one way to think of this, right, where we can use information from the past is, let's say we have some DP, right, where we have the number of tails and the number of heads. This seems, easy enough to think about. Now, if you're now taking, I, right, taking some I, we can say, okay, probability is pi for heads and 1 minus pi for tails. Okay, so if we use this as our DP, for each I, we can loop over all values of this DP, and you see which ones, and we see the probability, see which ones have a probability of more than 0, right? And then say, okay, that probability times pi, okay, so some DP, right, times pi is just equal to, tails, right, is equal to DP of whatever tails, and heads plus 1. And if we do here, whatever DP, we would just do that times, that would be the probability, right, times 1 minus pi. Okay, now let's look at the complexity of that. For each I, so that's n, times DP, right? So what's the maximum amount of tails? N. What's the maximum amount of heads? That's n. So that's n cubed, which is clearly too much, right? Because it's, basically 3 times 10 to the power of 3 is the maximum for n. So let's think about what we can do better. One thing we can see is there's not really a need to store both of these, right? It's kind of redundant, because if, let's say, we are considering all of the coins from 0 up to I, then whatever the number of heads is, the number of tails is just, is just I minus heads. So there's really no point having both of these. So all we can do, since we're doing this sequentially anyway, right? We're doing this sequentially, is all we have to store is, up to the ith coin, we just store the number of heads. And then we essentially do the same thing, right? So all it would be is, given, you take each I, right, from 0 to n minus 1, and you just consider, given all the ones previously, how can I, like, what is the probability given I flip this coin, right? So now for all, let's say j, it should be here, it's just O, to I, because you can maximum I. So all it is you'd have dp of I plus 1, including this new coin, and h, meaning if it's just h, meaning you roll the tails, right? Which is equal to dpi of j times p minus 1 minus pi, right? But if you do get a heads, then you would add plus 1 to the count of heads, and instead the probability would be times the probability of getting heads, which is just pi. And all you have to do is at the very end, dp of n, you would sum up all of the probabilities of n minus 2 all of the way to n, right? Because in these cases, if you know that the number of heads is more than the number of tails, right? If at least half of them are, if more than half of the coins are rolled as heads. This way, we've essentially eliminated a dimension, right, because it was redundant, and now our complexity is n squared, which works under the time complexity if it's 3000, right? 3000 squared works for our 2-second time limit. Okay, I hope this helped you, and thank you for watching, and I'll see you next time.